Great. It was really great session from the Norman, and we have another PowerPoint session about the event-driven architecture is one of the hottest topic in the whole API ecosystem. We have a Chaitanya with us.
Hey, hi everyone.
Hey
Yeah,
Chaitanya.
hi.
Yeah. Chaitanya is
Okay.
going to talk about how APIs and event-driven architecture are helping digitalization on the shipping industry. Stage is all yours,
Okay.
Chaitanya.
Thank you. So before begin, we'll start with the introduction. I'm Chaitanya. I've been working with the especially integration domain for all 13 years now. Currently working with Tabadul, for modernization of the uh, whole shipping related communication that they have. So if you are like if you hear like digitization in shipping industry, most of the people are unaware what is happening because whenever there is a word digitization, we start to associate it with either banking, finance, or the e-commerce, which are the happening industries. Shipping industry was uh, was untouched of this digitization wave. It started quite late. Uh, it was begin some 4 or 5 years back. The efforts were started, but still, if you see, it's not matching up the pace with, of digitization what is happening in other industries. So it's just a like big challenging here, as there are no like common platform or common standards that uh, like that we use for communication with different users here basically. So yeah, so that's what like we started here a couple of years back, moving with a great speed. So I'll try to explain what we have done and what are our different plans. Okay, so before going into the actual content, let's try to understand what exactly the shipping industry, or what are the different role players. So we have different for individual users like shipping agent, freight forwarder, or customer brokers. We who are basically dealing with the end customer for taking their goods and then managing those into containers. They are the end responsible of managing all your goods. Then what we have like port contractors. So port contractors are the one who are solely responsible of loading and unloading your container, managing them through customs. So these are like port contractors. So they are like quite one of the major players. And then we have a customs. Customs is the ultimate authority. They are the big boss. Whole approval, disapproval would be taken. The whole process of approval or disapproval of any container is managed by customs. So they are basically uh, I would say like the owner of the final approval. So they're the big boss here. And if you see the communication, most of the communication will happen between port contacts and customs, which will be very critical. That will have a sensitive data and the critical information because, as mentioned, customs are the big boss. They will approve, disapprove. So these communication between port contractors and custom is really of a great importance, or it's the most critical one here. Uh, so as the digitization was started in shipping industry, what happened like prior to that there were like different challenges. Most of the work was manual. The human intervention was a lot, which was resulting in multiple delays or missing consignments. Okay, just yeah. Okay, so these were the challenges before digitization. So when the digitization began, what happened? I'll try to explain. This is kind of the previous architecture that was firstly implemented. So what was happening? It was completely into a SFTP or a file-based, communication. So any communication coming from the consumer side, they used to put it on a SFTP folder, and then there was a whole middleware, application that's picking those messages, sending them to another SFTP location from where the end uh, processor or like a server application would pick it up, process it, and then once they have uh, any kind of event or message generated, again the reverse flow, like server application would send that message to a SFTP file. Middleware application would take it, process, do the transformation, and then put it to another SFTP folder, would be for the respective consumer application. So if you see here, what was happening is, the whole communication was a polling based communication, and polling is, highly resource you consuming, or high CPU consuming process. So this was, the major reason of, the delays, or uh, the lesser utilization of the overall system, or of either consumer or server. So which was resulting in, the delays of the messages file, missing files. Because if you see, the consumer used to poll the file as in when required, and if that file is missing at that moment, it would be, trouble. So imagine a situation, where as a port contractor, they have a customer at their gate, they are claiming their container, and customer has the final approval letter from the customs authority, but port contractor has no communication from custom. So imagine a situation, what kind of trouble that used to be, or there are lots of penalties involved in this. So uh, to avoid these challenges, there were multiple efforts being made. Like, there, the what was earlier implemented, we tried, with the API based microservices communication. But again, in that, what was a major challenge was the polling. So whenever, the polling is involved, it again, like, it's a last moment communication. So like, when you have some particular, customer, then you poll, and if there is no message or file available for this, then you are in a trouble. So, and also, like, other challenges, if we go with it. And yeah, so also, like, once the file is downloaded, there were, if you required it for, later point of time, there was no, channel, like there was no way of getting the file at later point of time. So if you have to reconcile the data, it was again a big challenge to, maintain the files, maintaining the records. So yeah, with API there were little progress. The communication was faster, but again with the polling, there were like challenges. So what we tried with this is to, to see, like, how event-driven API is answering all those challenges. So we'll move to this. Yeah, so before that, we'll try to understand what is an event. Event is basically any particular action, or yeah, any action which is triggered by the producer, and which can be a valuable information for those consumers. So it can be anything, like any update, or a update in the record, existing record, or any a new early created record, which can be important to any of the consumer. So that is basically an event. So event, what happens is, like, that event is published to a, common, I would say, like, queue, and then whoever has subscribed to those particular events, they will pick it up, and for rest, it doesn't matter. So uh, to give a specific example of event in this, shipping industry, see, if there's a container, which is at for the X-ray inspection, and they call it for, further manual inspection. So that message, whenever they are filling it, that failed X-ray inspection message is a trigger, or event, and that event is very valuable information for the shipping agent at port contractor. So yeah, this is about, what can be an event in specific shipping industry. And moving to the here, the architecture. Okay, so this is the main thing, what we tried here. So server, or basically, yeah, just moving back to the, the major role player. So if you see the slide number, yeah, this slide. So most critical the communication is involved in between port contractor and customs. So what we tried is, we tried to implement the event-driven architecture for these particular setup, because for shipping agents, freight forwarders, and the custom brokers, as the communication with the API to API communication was sufficient. Like, there were no challenges as such involved in that. So the first and We can, yeah, the first transformation that we took is between port contractor and customs. Okay, so moving to the event-driven architecture. So here, like for server, say we'll just treat to a specific example. Server application, we can consider as a the customs, and the client application we can consider, in this case, port contractor. So port contractor, there'll be uh, huge in numbers. There will be multiple application that you will be dealing with, and customs being, the sole body who will send all approval disapproval. So there will be lots of messages originating from this, server, uh, and then going to this individual port contractor, which are the, the client application. So for custom, they, for them it doesn't matter like who is owning the container or who is the end recipient of those messages. So for them it is just, to push it to or publish it to a particular uh, a queue or even streaming platform. And then it's, this middle layer, if you see, they would take care of uh, which particular consumer or the import contractor the message has to be sent. So if you see here, what we have done is, the customs, they would send it to a particular queue. Also, like it can be a Kafka or MQ or RabbitMQ. This is, any messaging layer which can make the message persistent and then do a content binds routing. Is this can be used here in this messaging layer. So once the message is routed to a particular, once the message is identified, like this is for which particular process and to which particular port contractor, it will be sent to a microservices. So what this microservice will do is it will identify this is for which particular consumer, if there any specific transformation has to be done, or if there are any specific requirement from this particular, like for particular client, this will be taken care by this microservice. And those microservices, what they will do is they will generate an event. So event is basically, what will happen. Event would have the actual message payload and the event details for so once, this event is published into this event hub, what it will do, it will first thing it will do, it will make it persistence. So once this event is persistent, so this can be, depending on the agreement, we can keep it in our, the storage for 3 months, 6 months, or any year, depending on the agreement. So it makes, very easy for any reconciliation of data or any customer coming back after a later point of time asking any missing events or particular events. It's very helpful. So this storage is the first thing what this event hub would do. Event hub does. Once the message is persistent, what it will do is, instead of sending the whole payload to the end client application, what it does, it only sends, specific information. So basically, what it will tell you, there is a event, this, like say, there is a X-ray inspection result available, and there will be a specific unique ID generated for that particular event. So only this information would be posted through a API layer to a client application. So with this, what happens? The client would just get to know, okay, there is a particular event available for me. If they are in a, state of processing that event immediately, they will come back. They will like get this event. They will mention the event details, and then event hub, with help of API, it will give the exact payload back to the client application. Or so in this case, like you can say port contractor. So with this, what happens? The initial communication where we are sending the event, it just contains minimal information, so it's a lightweight communication. So as from the server application, which is say like custom in this case, a huge number of messages would be coming, uh, and when we send or inform a particular event notification to client, only information like this event with particular id is available for you, only this information would be shared at first stage. And then in the later stage, they come with the same details and they download the actual payload of this with this event. So with this, what happens, the first step, the first step that happens within the this event communication is a lightweight. So there is no burden on the API gateway or event hub to process huge number of messages. And and if you see, like, this client application can be a random one, as I mentioned, like, there is not much digitization happening all over the shipping industry. So you are completely unaware of what this client application have in, how they have implemented, and whether they are in state of processing the huge payload that we are sending from here. So it's a good idea to just notify them with the availability of event, and when they are in, in need, or when they are in proper state of, or they require the event, they will come back and then get that event. So with this, if we make it like a synchronous process, and then kind of a decoupling is achieved, and it also makes the whole event communication I would say a light on the message sizes. So yeah, so about here. So as I mentioned, like, this event delivery, from event hub to the individual consumer application, it's a two-step process. So in first step, what happens? We just inform them about availability of an event, and with particular event name and a unique ID of that event. And then in the second step, the consumer come back to event hub, and then they download the payload. Uh, so this is about, the event notification delivery and the event download. So along with this, there are, additional features, which has to be considered for this design of event delivery or event notification framework. So the things that we experience, or we thought, during the whole process, we thought we needed all these features. So we implemented those one by one. So first is, the retrial of notifications. So basically, what happens, if you see, uh, these client application can be, modern ones or the legacy ones, but with the API. So we don't know what exactly, what technology or how capable they are of, getting or processing the events, at if there are huge numbers involved. And also, like, as these are like third party client application from like from this particular event hub and API layer, there can be a scenario where network is unavailable or network is slow. So there are chances that whenever the notification is pushed, it is lost or timeout. So it is very important, to manage or define the retries. So what happens, sometimes the network is just unavailable for fraction of second, and if the same notification is retried uh, after, say, within milliseconds, it goes successful. So instead of marking that event as a failed within, the first attempt, it's always better to retry. So during retry, uh, yeah. So during retry, there are few things which should be, considered carefully. So the first thing is number of retries. So see, number of retries usually, that's the standard. You'll see, like, between 3 to 5 the retries, between 3 to 5 retries are tried, but it should be designed in such a way that it doesn't burden your, the event hub, for just, it is busy with the retries itself. So depending on the criticality of messages and the criticality of the end consumer, the retries, or number of retries are to be, defined carefully. The second thing, which has to be taken care, is duration between the retries. So also, yeah, see, why this is important factor is, see, if you keep on retrying a specific interval for say n number of times, then what you are ultimately doing, you're loading or consuming most of your overall resources of this main event hub, which also has to, cater to multiple consumer application. So what ideally you should do is, this duration between each retry should increase. Like, after first attempt, it should increase by some base factor. There are, some industry standards available for it, but it should be uh, tried and tested for your own setup, and then conclude on the final number. So number of retries and duration between the retries is something has to be, carefully uh, decide. Then we have a timeout. Again, like, see why timeout is important here. As I mentioned, these client application are completely opaque or obscure to this API and event hub layer. we should take care of the timeout in well manner. It shouldn't happen that you like this application is down and the timeout defined are very high, and a particular application, when it is down, the API and event hub resources are just getting consumed for delivery of one particular client application. So the timeout should be a small value, so that if there is either a network or end consumer application issue, it should immediately mark it as timeout, so that the resource utilization is not burdened. And then another point to consider during this notification framework design is detail logging. As we are dealing with multiple consumer applications with huge number of messages, there will be conflicting scenario for sure. So either because of the network delays, or say some issues from the event framework or from the client application, there will be conflicting situation where client is coming and then asking where is my event, I did not receive, or I want it back, or something, payload is missing, we didn't receive on time. In order to avoid all such conflicting situation, it's always better to log each request and response which is sent to this consumer application with a unique global transaction ID, so that any conflicting situation, the log should be available to operations team handle it. But it shouldn't be it should not come to a development team for any debugging or any further analysis. So these are like three things which should be taken into consideration for designing a event notification framework. Coming to this specific API, the APIs which this event communication, the APIs which will facilitate the event communication. So, what should be, what should be the basic thought while designing these APIs? This client application can be a modern one or the legacy one. And these, particular clients, which can be, the port contractor or shipping agents, they may not be a tech savvy, or they may not be having their own, big IT setup. So the API that are to be defined, they should be descriptive. They should be simple to implement. And they should be, self isometric. They should be, like if you're following open API specification, you should include all the, examples, the data types, the mandatory, non-mandatory fields. And also, if you're dealing with the local language, always try to make the, the examples of English as well as local language, so that it helps, for a for a developer with better understanding of the overall API. About adaptation, yeah, see, this is also like important point, easy to adopt the changes, because the customs authority, who is the main source of generating all kind of communication, any changes resulting in the event, at an event, sorry, the customs side, it has to be implemented by a huge number of consumers, like port contractor or shipping agent. So the APIs should be designed in such a way that any changes, like a regulatory or governmental changes happening at a customs side, should be easily implemented in the API, and it shouldn't be a burden or a big changes for big efforts for the end consumers while adopting to the changes. So this should be the the major consideration while designing those API. Another important point is the follow the industry standards, because as there are multiple consumers, and the one, yeah, the one source which is generating the message, and there are multiple consumer applications, it's always good to stick to a particular standards, and then uh, follow it consistently. Because what happens, all the small steps in the whole shipping industry, they will have some reference, like say, if you have a container and the declaration is done for it, the next step, like whenever declaration is initiated, there should be some reference of the earlier stage. So every step should have a, the reference of earlier stages. For that, try to use a standardized standardized naming, so that it's easy to identify the references between each step. And yeah, the another important point is about security. So the whole communication between this customs and the port contractors, they will carry some sensitive data for sure. It should be highly secured. So standards like the data should be encrypted during transit, as well as when you are storing it, it should be encrypted. Or or for us, the stored data, any critical information should be masked. These are few things to be taken care. And also, like, it shouldn't happen that when we are focusing on security, it shouldn't make the whole the communication between the client and the API layer or even complicated, because this client application, as I said, like, they may not be a tech savvy company, so it should be easy to implement. So what we have done in this case is, as this is application to application communication most of the time, we are using a OAuth, which is a credential base. So there are not, it's like easy to implement, and same time it's a security. So we're not compromising at the security, but it's again easy to implement. So this should be a the point while designing those API. Yeah, so this is about the event and the API design considerations. And at the same time, what we are doing, the other interesting point that we are doing is, like, we are implementing a blockchain setup, to reduce the fraud. So we are working with the multiple custom authorities and port contractors, so that every transaction is marked at the blockchain server, and then we collect the data using API, sharing with those customs authorities, so that the fraud is reduced. IoT devices is something interesting happening all over the industry, to tackle various challenges, environmental as well as industry specific standards. IoT is something which is interesting thing happening. And then there is another, good thing is marine APIs, to tackle the environmental challenges. So if to just to give you, interesting example, we have an API which gives you the information about the movement of different, fish or whales around sea, so that the routes can be planned according to it. If there are any specific, congestion or traffic happening, you can get that information on using the API, and then you can plan your route accordingly. So in order to save the cost overall, and also the fuel consumption. So these are like something interesting thing that we are working on.
Okay, Chaitanya. Thank you very much. Sorry for the disturbance, but it's we are time constrained.
Ah, yeah.
So yeah. So folks, if you have any question for Chaitanya, feel free to reach out to him on his LinkedIn or Twitter.